Now in this part of our video, that is about the magnetic effect of electrical current, we are going to study the properties of magnetic field lines. In the previous class, we defined what are magnetic field lines. So I told you the magnetic field lines are the lines along which a north pole would move if free to do so. If we have a magnet and near to north pole of it we keep a compass, then the path it follows, that path is magnetic field line. The first property comes that they emerge at north pole and merge at south pole, which in another means that people say that they originate or they come out from a magnet at north pole and they enter into a magnet at south pole outside the magnet. Outside the magnet they start moving from north pole and they enter back at the south pole. Though the inside they move from south pole to north pole, outside magnet they move from north pole to south, inside the magnet they move from south pole to north, and these are continuous lines, they are not broken ones, they are throughout. So they emerge at north pole and merge at south pole. The obvious question asked, why should it be? Why should they emerge at? So as the definition goes, I have told you definition while defining this. Now this we can rub. Okay, if I have a magnet like this, says this is the north pole and this is the south pole. If I keep a magnetic compass, which undoubtedly is a small magnet, near to it, then it will follow a path like this. So that is how we define magnetic field line, that the path along which a north pole will move. So that definitely this defines or it explains it, okay, why it a magnetic field line emerges at north pole and merges at south pole. Outside they move from north pole to south pole, inside they move from south to north. Second point is they are closed and continuous. It somebody could think, okay, they are moving here and they end here, they start from here, they end here. No, they are continuous and they are closed. Continuous means they are not broken like this also, they are continuous and also they are closed, that is they move like this. Wherever they are closer together, the field strength is more, and wherever they are farther apart, the field strength is less. To explain this point, let me draw it here again. Okay, this is the magnet. A field line travels like this, another one will travel like this. Let us take it like this. Now at poles, if you see, the distance between the two magnetic field lines is less. Let us say this is north pole, this is south pole, so they are now near the poles they are close together, and other place, let us say this is another place, they are widely separated. So let me tell you, near the poles they are close together, other places they are widely separated, and the obvious thing will be that wherever they are close together, field strength is more, and wherever they are farther apart, field strength is less. So we have covered this point also. Near the poles they are very close to, this has already been explained. Now there is one more characteristic of magnetic field line, and that is very important out of these all, and that is the two magnetic field lines, if are produced by the same magnet, from the same magnetic field, you can say, they will never intersect each other. Two magnetic field lines, if are produced by the same magnet, they will never intersect each other. And to explain the point, let us say, assume contrary to what we said. Okay, let us say at point A, these two magnetic field lines intersect with each other. That means if you want to draw a tangent at this point, one will be like this and somewhere another will be like this. That means you can draw two tangents at the same point of intersection. This can, in another words, also be told that if we assume it this way, that two magnetic field lines produced by the same magnet can intersect with each other, then while defining the direction of magnetic field, we told direction of magnetic field at a point is the direction in which the north pole of the magnetic compass points when kept at that point. So if you keep the magnetic compass here, then one will be this direction and another will be this direction. That means if you assume this, that it is possible for two magnetic field lines to intersect with each other, then at the point of intersection, when a magnetic compass is kept, it is supposed to point simultaneously at one point of time in two different directions, which is not possible for any indicator to do. That means it is not possible for these lines to intersect with each other. And one more point is we are left with, that is the, if magnetic field lines are parallel to each other and also these are equidistant. See, both the points are important. They must be parallel and also they are equidistant. Not it is like this, okay, here distance and like this distance. They are parallel but they are not equidistant. So our condition is if magnetic field lines are parallel to each other and also they are equidistant from each other, then the field strength will be uniform. That was all about the characteristics of magnetic field lines.